Hi, so today we've got yet another bit of DNA analysis equipment. This is a PSQ96 pyrosequencer. I have no idea what pyrosequencing means. I have no particular interest in researching it. I'm sure there's plenty of info online if you're interested in that sort of thing. I suspect it's probably going to be another variant of camera with some sort of funky optics and all the magic being in the chemistry. Totally sure the vintage of this, I think it's a bit older than I originally thought. There's an embedded PC running Windows NT4, so that dates it a little bit, and all the cards are ISA. Looks like a sort of very large laser printer basically. The only user interface, you've got 4 LEDs on the front. It has a monitor and keyboard and mouse type input. It's got a built-in embedded PC. If we open the top up, we can't see a great deal. There's a compartment here that presumably your sample, I think it's like an array of samples, and this will read sort of multiple samples in an automated operation. I think this whole section moves around. So I think there's probably a large tray you can put. I think it's 96 samples, which is why it's called PSQ96, and presumably want to analyse all those 96 one at a time, or maybe in parallel, I don't know. And this block lifts out. Can't really see a great deal. There's some, looks like some lens, like a plate with some lenses moulded into it. Around the back, we take the rear cover off. Got a big power supply here, some sort of specialist camera that goes into this card here, and this is just a card cage which has got a single board PC and various other sort of custom interface cards in it. As I think we've seen before, these outer plastic casings are made out of polyurethane, which I think is basically done using fairly low cost sort of wooden tooling, because these are relatively low volume, but because of the high price, people expect a nice high quality finish. All the outside casing is sort of quite large complex pieces, so you couldn't afford to do sort of proper hard tooling for those, because it would just cost all the astronomical. But I think this produces quite a nice sort of finish quality. It's sort of a nice metallic paint finish with a lacquer on it, with relatively low tooling cost. And opening up the back, we can see there's 2 stepper motors. This whole carriage assembly can move in 2 directions, so we've got forwards and backwards. Let's move this section here on these lead screws, and left right moves the whole thing across. So this is the lens array is static, so everything above it is moving. So this is sort of moving this top assembly over that 96 element lens array. I'm not yet sure exactly how this works. I've not been able to find any detail on the consumables and so on. This top section's got a sort of rubber sort of soft seal that goes over here, and looks like there's 8 sections around here. This whole top lifts up, but this array here is static, so I think maybe the camera is looking at this whole array, and maybe this moves sort of samples to various positions on it. I'm not or perhaps this drops samples in. Oh, it's a bit weird. Perhaps there's a plate that goes on here with the various reagents on it, and it then somehow transfers it through here. There's a set of 8 pneumatic valves here. I think there's probably an air pump inside here. There's no external air port on it, so maybe this is used to transfer, sort of blow, use pneumatics to perhaps blow samples down into the that area. I'll have to see if I can find some more information online, because I can't quite figure out which bits go where at the moment. And if we take this off, we see there's just these 8 pneumatic lines coming into this rubber pad, so this is just clearly blowing something down here, whether it's sort of pushing something down here. And taking this top piece apart, we've just basically got the mechanical sliding assembly. We've got lead screw nut here, and some sort of travelling cable chain here, which carries the 8 pneumatic tubes. And this PCB here is basically just interconnect. This is part of the assembly which slides across this way, which has got a manifold with the 8 pneumatic valves and just connections to a ribbon cable for everything. And this is the incoming air supply on this sort of curly cable, because this whole thing tilts up this way and also slides across. So this is supposed to be nice and flexible. Something that does seem a little bit silly on this board is it's got sort of all through-hole connectors and so on, and it has 7 surface mount parts on there, and it hardly really seems worth it when, for a board that size, just to have that many parts. But obviously these things aren't particularly cost sensitive, but so it seems like overkill. Yeah, if you've already got surface mount, if you've already got all this through-hole, not really sure there's much point of just having those 7 parts of surface mount rather than doing the whole thing as through-hole. And the inside of this block assembly, it is a temperature control system. We've got this flex PCB with lots of wiggly traces on there, which is acting as a heater. And then this little PCB, we've got a temperature sensor that's buried in the block down there, and there's just a thermal cutout switch there, and that just, there's some spring contact pins that just connect to the bottom half when the lid gets closed. Obviously all these chemical processes are somewhat temperature sensitive, so this just heats up and maintains it at whatever temperature it needs to be at to work. So I've taken the top plate on, and this is the underside, and looks like this lens array is actually connected to this rather complicated looking motor assembly. But all it seems to do is, as the motor turns, it just rotates this whole plate in a roughly 1mm diameter circle. So I can only assume that so that it can actually look at sort of all parts of a sample. You know, so you're not relying on precise positioning of the whatever it's looking at. Although this is just a DC motor, there's no gearbox, so this feels like it's meant to go around like continuously rather than being sort of controlled to a specific position. There is an encoder on the back of the motor, but if this was going for a position, I'd expect this to have some step down gearing. It doesn't feel like it has, just by how easily this moves. On this board it does actually show sort of stepper motor option, which isn't used on this interconnect board. And on the bottom here there's a Peltier cooler with a heatsink. It's not totally clear what this is cooling on. The cold side is up here, but this is all sort of plastic. There may be a metal bracket going down on the front of the Peltier, but I think this is probably just providing some background cooling to offset the effect of that heater heating the block, so it can maintain a constant temperature. Obviously if you've only got a heater, then if it overshoots, then you've got to wait for it to cool down, so this is probably just applying some active cooling to try and maintain a constant temperature. Okay, thinking a bit more about this sample thing is also part of the section that's sort of moved around as far as the motor up. You can see there's a You can see it sort of just shaking and shimmying. I think this is just for sample agitation, so it's just shaking the liquid around so that it doesn't sort of all settle, rather than any clever optical stuff. So looking under where that top plate was, there isn't really a great deal more. There's just the camera that's bouncing through a mirror looking straight up at this plate. So it seems what it does, it uses the compressed air to do something, maybe push a sample or move it vertically, or try and do a bit of research to find out what that is. It can sort of jiggle it about and then sort of look at it through those lenses. There's no light source in the top, so this is clearly using an effect where the sample generates light as part of the chemical process. Probably also suggests this is probably a fairly sensitive camera, because these effects are usually fairly small, so might be a vaguely interesting camera in there. The only other stuff that's in here is we've got a little very small air pump and an air reservoir here. There's also this pneumatic cylinder. Now this isn't actually connected to anything. What they're doing is they're just using this as a damper for the main lid opening closing mechanism. They've just put some flow restrictors on here to limit how fast the air can come in and out of this. So this just acts as a damper, like an adjustable damper, using an off-the-shelf pneumatic cylinder. And this is the air compressor assembly. You've got this little pump here. Obviously this thing only uses very small volumes of air, so there's just this tiny little pump here. This is an air filter, so the air comes in here, goes through the pump, then goes into this reservoir, comes out the reservoir, then goes through this filter unit into the actual main, that top unit we saw. There's a tube here which goes down to a pressure sensor on this little board. Interesting, there's an Altera CPLD on there rather than a processor, which seems a slightly interesting choice. There's a 12-bit analog devices A to D converter on there to read the pressure sensor, and at the bottom the bottom end of this filter, which is to capture moisture. So obviously if you're taking air in from the outside, there's going to be moisture in it. And also the vent at the bottom of the reservoir goes through this sort of exhaust valve, and this is like a sort of silencer. It's like a sintered metal thing, so that when it vents air out, it doesn't make a huge amount of noise, so any excess moisture will also get vented out of there. So this is the camera assembly. This is just a light guide pipe, and so there's a mirror here, an adjustable mount here so that the camera distance can be moved, presumably for focusing. Taking all this off, we can see we've got this rubber bellows assembly to allow it to move. There seems to be a lot of light proofing, so this is clearly working at fairly low light levels. It's quite an unusual sort of cylindrical camera assembly. I don't know whether this is going to be a cooled CCD or something more normal. It's not particularly huge though. It's a fairly compact little unit and a fairly average looking lens. This is the lens. This looks like a fairly normal C-mount CCTV lens. It's quite a wide aperture, 0.95, 17mm focus length, and this was set wide open, and obviously the focus and everything had just been locked down with a bit of goop, but actually not so badly that you can't actually recover it. Some things I've taken apart where they've just glued the lens together, so it's pretty much useless, but that's still a fairly usable lens. And the camera itself, there's no manufacturer's name on it I can see so far. It says MX5 camera, but haven't found anything on that. It's a 15-way VGA style D-connector with unusually with slide locks rather than screw locks. There is like a sort of window in front of the sensor, so I suspect this might actually be a cooled camera, and there's like a vacuum cavity there. I can see what looks like some wires down the side, which I think could well be for a Peltier cooler. So let's take a look inside. And I think also because this is an aluminium body, it may well be this is designed to get rid of some of the heat from the Peltier cooler. So this is the camera unit, and there's actually surprisingly little in it. There is a sort of vaguely sealed assembly in the front. It definitely isn't on a vacuum like that big Spectral Instruments camera we found in the 454 analyzer. So you've got the little CCD chip here, bonded onto a little Peltier cooler, onto this sort of heatsink, and really not very much. There's a Sony chip, which I imagine is probably a CCD driver. There's some 4000 series CMOS, and there's a 12-bit A to D converter. So not really a great deal. I'm guessing the timings probably come from the PC control card, so they just put as little as possible in here. Looks like it's probably a few voltage regulators, all these caps. Yeah, 788L05, 788L15, and just a few other analog bits and some CMOS. I managed to crack this sensor off the cooler. It's a pretty bog standard black and white video camera sensor, Sony ICX056. It's 510 by 492 resolution, so 250k pixels, so just like TV resolution type sensor. And all I've done is add a cooler on it to improve the noise performance at low levels. Can't see any sign of a manufacturer name on the camera other than MX5. I can't find anything online, so I would imagine it would be a bought-in camera rather than made custom, especially as it doesn't seem to be particularly exotic spec-wise, but I can't see any manufacturer name in the camera. There might be something on the interface card. So this is the camera board driver, and I think this actually is custom made by the manufacturer that did the rest of it. So in there's certain styles, like for example these green headers, and the style of the layer indicator, which just says LAY dot, is very similar to the style of this. So I think this is actually a custom one. This board also is dedicated to a sort of cooled camera, because there are some mentions of the cooler on the board, whereas you might expect that if you're buying an off-the-shelf camera, perhaps the interface board might only deal with the video side, and there might need to be a separate board for the cooling side of things. So it's a bit unusual. It looks like they've custom made a camera rather than buying one off the shelf. So this is an old ISO bus. The date on the card is 1998. Big Altera FPGA, some RAM, just some interface components, nothing particularly surprising or special on there. All these boards are mounted in this car cage. It's like a passive ISA backplane and a single board PC. I did try booting this up, but I got quite a lot of error messages and then a Windows NT login prompt I didn't know the password to, so couldn't get anything obvious to happen with that. I'll have a look on the disk, see if there's anything interesting. But and this pair of boards controls all the hardware in the unit. The power comes in on this connector, a little bit of filtering on here, some ferrite beads, and goes up to this board. This splits out power to the passive backplane for the PC stuff. I think these are actually filters rather than switch mode supplies. There's no other components, it's just the two filters, a load of various filtering components, and that connects to a ribbon cable down for the signal connections. And these are the connectors to the various parts of the main unit. Interesting, they've got these jumpers, looks like pretty much every pin has a jumper on it, so they can disconnect for testing, which is not seen that done before. Every single pin on this looks like it's disconnectable. And the baseboard, again, we've got another Altera FPGA. I think that's some sort of BIOS or identifier, EEPROM. There's 3 heatsink chips here. I'm sure these will be the stepper motor drivers. There's some ADCs there, fairly low res ADCs, and some Darlington drivers, which will be for those pneumatic valves. And I think some linear regulators here, but nothing particularly. It's just sort of bunch of custom interfacing stuff. And this is the PC. It's Advantech PCA6751 266 megahertz Pentium board. So this has basically got all the parts you'd find on a sort of typical PC motherboard of that era in a sort of industrial format. You've got some memory here, compact flash slot there, memory backup, and pretty much sort of PC chipset, and just all the connectors for this supports LCDs as well as VGA monitors. Interesting, they had a serial mouse connector on it rather than USB, although this does have USB as well. It's probably a fairly early USB, so it's running Windows NT4. We've seen these embedded boards before. Again, you wouldn't create your own PC in a product. And there's just a hard drive in here. Let's try reading that, see if I can find any info on it. I did read the disk. There's really absolutely nothing interesting on there. There's no data files at all, just the software. So I think this was probably run using the network to store all the data, which is sort of makes a fair amount of sense for this sort of thing. So no interesting image files or anything. So again, this looks like another sort of case of very fancy camera and all the clever stuff being in the funky chemistry. There do seem to be quite a lot of DNA analyzers of various flavours floating around fairly cheap, but unless there's any that I can find that are significantly different, I don't think I'll look at any. If anyone knows of any sort of different tech or anything that might be interesting to look out for, then please put it in the comments, because these because of the advances in DNA analysis, a lot of these old machines are sort of turning up on the surplus market, but pretty much all of them seem to be sort of funky chemistry plus camera. So let me know if you know of anything that might be interesting and different in that respect.